two bodies of different masses are dropped simultaneously from the top of a tower if air resistance is same. So air resistance is there, it is remains, so it is not air resistance is not negligible. Okay, the air resistance is same on both of them. Option 1, the heavier body reaches the ground earlier, the lighter body reaches the ground earlier, both reaches the ground simultaneously, cannot be decided. So the answer is lighter body reaches the ground earlier. Option 2. Now a lift is freely falling from 8th floor and is just about to reach 4th floor. Taking ground floor as the origin and positive direction upwards for all quantities, which one of the following is correct? X is less than 0, V is less than 0, A is more than 0. Option 2, X is more than 0, V is less than 0, A is less than 0. Option 3, X is greater than 0, V is less than 0, A is greater than 0. Option 4, X is greater than 0, V is greater than 0, A is less than 0. So the answer is X is greater than 0, V is less than 0, acceleration is less than 0. In one-dimensional motion, instantaneous speed v satisfies 0 less than or equal to v less than v0. Option 1, displacement in time t must always takes non-negative values. Displacement x in time t satisfies minus v0 t less than x less than v0 t. The acceleration is always a non-negative number. The motion has no turning points. The answer is displacement x in time t satisfies minus v0 t less than x less than v0 t. Option 2 is correct answer. Next one. At metro station, a girl walks up a stationary escalator in time t1. If she remains stationary on the escalator, then the escalator takes her up in time t2. The time taken by her to walk up on the moving escalator will be option 1, t1 plus t2 by 2. Option 2, t1 t2 divided by t2 minus t1. Option 3, t1 t2 divided by t2 plus t1. Option 4, t1 minus t2. So the answer is option 3, that is t1 t2 divided by t1 plus t2. Next one. Two bodies of different masses are dropped simultaneously from the top of the tower if air resistance is proportional to the mass of the body. Option 1, heavier body reaches the ground earlier. Option 2, lighter body reaches the ground earlier. Option 3, both reaches the ground simultaneously. Option 4, cannot be decided. So the answer is option 3, that is both reaches the ground simultaneously. Choose the correct statement. If a particle is in motion, average speed always equals average velocity. Particle can travel with constant velocity and variable speed in given Choose the correct statement. If a particle is in motion, average speed always equals average velocity. Option 2, particle can travel with constant velocity and variable speed in a given. Option 3, if acceleration is constant, speed is constant in a given direction. Option 4, if a particle travels along a straight line, average speed equals average velocity. So the answer is 4. If a particle travels along a straight line, average speed equals average velocity is the correct statement. Next, the acceleration of a moving body can be found from area under velocity time graph, area under distance time graph, slope of the velocity time graph, slope of distance time graph. So the answer is slope of velocity time graph. So acceleration, right? For a moving body at any instant of time, if the body is not moving, the acceleration is necessarily 0. If the body is slowing, the retardation is negative. If the body is slowing, the distance is negative. If displacement, velocity and acceleration at that instant are known, we can find the displacement at any given time in future. So the option is 4. For a moving body at any instant of time, if displacement, velocity and acceleration at that instant are known, we can find the displacement at any given time in future. Next one. A body falls freely from a height h. Its average velocity when it reaches the earth is option 1, square root of gh, option 2, square root of gh by 2, option 3, square root of 2gh, option 4, g into root h. So the answer is option 2, that is square root of gh by 2. A body falls freely from a height h after 2 seconds. If acceleration due to gravity is reversed, the body, option 1, continues to fall down, option 2, fall down with retardation and goes up again with acceleration, option 3, fall down with uniform velocity, option 4, rises up with acceleration. So the answer is fall down with retardation and goes up again with acceleration, option 2. Next one. In the given above problem, if we assume that the gravity disappears instead of getting reversed, the body continued to fall down, option 2, fall down with acceleration, option 3, fall down and floats, option 4, fall down with deceleration. So the answer is continue to fall down.